Guys, welcome back to Math with OG. In this video, we'll be looking at symmetric difference of sets. Let A and B be two given sets. The symmetric difference of set A and B is noted with this symbol, more like a triangle, looking like a triangle. I think that's symbol delta. Symmetric difference of A and B, so this is how I represent it, is the set A minus B, A difference B, union B difference A. I believe in our last video, we talked about A difference B and B difference A. So let's use an example to explain that. Now, given a set A, 1, 2, 6, a set B, given as, let's say, 2, 7, 9, A difference B is the elements you can find in A that are not in B. So that is simply 1 and 6. B difference A are the elements you can find in B that are not in A, and I believe that is 7 and 9. The symmetric difference of A and B is simply A minus B union B minus A. Now, what is the union of two sets? Everything you can find in both sets. So I can say symmetric difference of A and B is the union of these two guys, which is simply 1, 6, 7, 9. And as you can see, it is everything you can find in A and B except what is common to A and B. So that's another way you can put it. Everything you can find in A and B except what is common to A and B. So that is symmetric difference. Now, symmetric difference of A and B using rule method. Remember, you can have more than one ways of writing a set in rule method. One of the ways you can write symmetric difference in rule method is X, such that X is a member of set A and not a member of set B, or S is not a member of set A and a member of set B. So this guy is for A difference B and this guy is for B difference A. Now the union, that's why you have or this, combine them together, it will give you the symmetric difference. Now if I were to use Venn diagram to represent symmetric difference, we have to use Venn diagram to represent symmetric difference. So you can see here A only is for A difference B and B only is for B difference A. Now the union of both of them will give us the symmetric difference of A and B, and as you can see, we don't include what is common to A and B. So that's another way to know it. Just list out all the elements in A and B and clean out what is common to A and B. That will give you the symmetric difference. And similarly, for this case, what we have here is simply disjoint set. So A only is everything in A, since there's nothing common. B only is everything in B, since there's nothing common. So a symmetric difference, you shade everything in A. This is for A difference B, and this is for B difference A for disjoint set. So here I can say if, let's write it here, if A intersect B give us empty set, that means A and B are disjoint sets. If A and B are disjoint sets, so that's what we have here. A intersect B give us empty set. If A intersect B, if A and B are disjoint set, then I can say A symmetric difference of A and B is equal to A union B. Symmetric difference of A and B is equal to A union B. Can go back to our previous video when we did the union of disjoint sets. We found that we shaded everything in A and also we shaded everything in B. So the symmetric difference of two sets can only be equal to the union of those same two sets if they are disjoint sets. So that's one other rule you need to know in case you are tested on it when writing OBJ based exam. Let's say if A intersect B is equals to an empty set, which of the following is true? So it's simply symmetric difference of A and B is equal to the union of A and B. Now let's play with this question now that we understand what it means to find symmetric difference. A is equal to this set, B is equal to this set, C is equal to this set. Find the symmetric difference of A and B. And okay, lest I forget, remember that the symmetric difference of A and B is the same thing as the symmetric difference of B and A. That means symmetric difference, this operation is commutative. So we'll talk more about what commutativity means in an operation when we move on to binary operation. Commutativity is a term we use in operations that are binary. Okay, let's put it that way. Operations that are binary. That's union of set, intersection of set, your addition, subtraction, your multiplication, multiplication of matrices, addition of matrices, as the case may be. So I'll explain what commutativity means better when we enter binary operation. But just note that your symmetric difference is also commutative. That means the symmetric difference of A and B is equal to the symmetric difference of B and A. That's what it means for the operation to be commutative. Now, symmetric difference of A and B. Like I said, the shortcut for getting your answer, list out everything in A and B and remove what is common. Because if I'm to ask you what is A minus B here, you will say 1 is part of the set, that's A difference B. 2 will not be a part of the set. 3 will be a part of the set. 6 will not be a part of the set, and 8 will be a part of the set. Because you can see 1, 3, and 8 are in A, but not in B. Now, if I ask you what is B difference A, 2 will not be part of the set. You are going to have a 5, you won't have 6, you will have a 7, and you will have a 9. So you'll be having 5, 7, and 9. So as you can see, if I'm to list out the symmetric difference, just bring out what is not in A and B. So that is 1. There's no 2. You have a 3. There's no 6. You have a 5. You have a 7. You have 8. And you have 9. And as you can see, 1, 3, 8 is A minus B. 5, 7, 9 is B minus A. The union of both of them will give us the symmetric difference of A and B. And what is the shortcut? Eliminate what is common. So let me use another color to eliminate what is common. You have 2 to be common, eliminated. You have 6 to be common, eliminated. So 1, 3, 8, 5, 7, and 9 is the symmetric difference of A and B. Now let's move on to A, symmetric difference of A and C. So list out everything, eliminate what is common. For A and C, I have 1, not common. I have 2, not common. I have 3, not common. I have 4, not common. I have 5, not common. 6 is common, and 8 is common to A and C. Lastly, symmetric difference of B and C. For B and C, I have 2, not common. 5, okay, we have 4, not common. 5 is common. 6 is common. 7, not common. 8, not common. And 9, not common. So that is how you find symmetric difference of two sets. List out A minus B, list out B minus A, add them together, you get a symmetric difference. Or list out all the elements in A and B, eliminate what is common. So that's that for symmetric difference of sets. Now next video we'll look at other aspects of sets.